Okay, so let's start. So first of all, welcome to the this fifth day session 2, and due to some reasons, Dr. Mani Madhukar, who was scheduled to be here today for introducing hyperledger fabric, he is unable to join, and therefore I happen to discuss with you what is Hyperledger Fabric and how we can use Hyperledger Fabric platform for creating our own network. So talking about enterprise blockchain, we will be taking Hyperledger Fabric as a case study to see how enterprise level blockchain can be, applications can be developed. So if I look at the blockchain architecture, my dear friends, based on the type of decentralized applications, whether it is for healthcare, for mesh services, for audit, or for any other service, for pure cryptocurrency transaction, based on the kind of decentralized applications and the requirement of an organization to have decentralized application where they would like to have some kind of authority to be given to each individual. Based on these two requirements, several types of architecture have been introduced, right? These architectures depend on dApps running on blockchain, and they may have, please allow me to allow me to stop my video because I would like to have a better connection. Right now we are suffering from some kind of disconnection due to fiber cut in the nearby place. So these apps running on blockchains may have nodes with data ownership. For example, we can think of some auditing process where there are nodes, there are people who have some kind of data ownership. Finance and accounts may have some kind of data ownership. HR department may have different kind of data ownership. So for these enterprises, we can have data ownership from different people. And application may demand different type of access control on the data. For example, I may be given access to view my data, but not the data of another employee. So accordingly, blockchains are classified as public, private, permissionless, and permission based on the ownership of data and access limits. So if I look at this beautiful division of architectures, how architectures can be explained. So architectures based on read, write, and commit permission, as you can see, read, write, or commit permissions granted to participants. They can be permissionless or permission. For example, cryptocurrency, Bitcoin is a permissionless blockchain. Anybody, everybody has got everybody can join, read, write, and commit. It is hosted on public servers, and by public servers means those people, those nodes which are participating in the network. It is anonymous and highly resilient, but at the same time, it has low scalability compared to others. So permissionless and permission is based on the type of read, write, and commit permissions granted to the participants. Whereas it is known as public or private depending on the ownership of the data infrastructure. So as I told you that the data infrastructure can be owned by, say, some hospitals, or for, in case of HR department, some HR department person. Accordingly, this is defined as public and private. So as you can see that in public permission, anybody can join, read, write, and commit. on public permission, anybody can join. So anyone can join and read. Only authorized known participants can write and commit. So it has got medium scalability, right? Because as I told you that only HR people who have got HR admins, they can write and commit. I have writing permission to my own data, but that will be authenticated by the HR admin department only. Now, private, in case of private, only authorized participants can join, read, and write. For example, if I wish to run a blockchain application in my own organization, where we have HR department, we have finance department, we have academic section, we have student section, then only people who have got the certificate that they are bona fide member of IIIT DMJ will be allowed to participate and hosted on private servers, whereas private and permissioned have, that they have some kind of permission is required for the write and commit. So what is the difference between private and permissionless? As I told you, for running the MES service, every student will have equal right, and there will be MES contractor, MES service provider, he will also have equal right. But this will be a permissionless private MES service blockchain application, where the student can, the moment he joins a MES on a specific day, his attendance is counted automatically, and all those services which are provided by MES contractor are also automated. So by this, I mean private and permissionless. So now, what is an enterprise blockchain? So enterprise blockchain is a type of permission blockchain for streamlining business in large enterprises, maintaining the privacy and security, and reducing the operational cost. Many large enterprises are now want to have decentralization, because you know that in this cyber physical system, many quick decisions are required to be taken immediately. For this, one does not need, whether it is manufacturing or supply chain, every single decision at different points requires to be taken immediately. How this can be made possible? If the services are decentralized, if the various ownerships are also decentralized. So accordingly, enterprise level blockchain have been introduced. So several blockchain platforms, if you find, are there. Hyperledger Fabric is one of them. Ethereum Enterprise is another. Quorum is third. In fact, there are several blockchain platforms that are there to develop enterprise level blockchain. So today we shall be trying to understand how enterprise blockchain networks can be created and business can be performed on those blockchain networks. So to begin with, I will start with Hyperledger and then Hyperledger Fabric. So what is Hyperledger? Hyperledger was basically an effort, a collaborative effort, which is open source, created to advance cross-industry blockchain technology. Because as I told you, that blockchain is a technology that has potential to streamline many things in a more decentralized way. And people and industries have found out that it has got huge potential. And therefore, many companies joined hand to start research and development in blockchain technology at the concept level, and then at the implementation level in their own organization. So basically, Hyperledger is a global collaboration hosted by Linux Foundation, and there are huge number of participants, including leaders in finance, banking, Internet of Things, supply chain, manufacturing, and other technologies. So blockchain, in case of enterprise level blockchain, we must have customized permission and structure. So every enterprise needs special features and modifications to help a blockchain achieve its intended purpose. For example, blockchain can be for HR management, blockchain can be for health management, blockchain can be for many different purposes. Accordingly, special features and modifications are required. So there can be many open source solutions for blockchain with different features that you must have seen by now that provide a wide range of solutions across many industries. So what Hyperledger does is that it provides an environment to incubate new ideas. Your idea could be identity management. Your idea could be, say, management of the organ donation things, because you know that organ donation requires a lot of care and support and management. So in how it can happen through blockchain applications. You have recently, many of us know that we recently came across the world witnessed COVID-19, where remdesivir injections were not reaching the right people, oxygen cylinders were not reaching the right people, people were stocking those things for their future use, which they actually did not need to stock to. So how do we ensure a transparent system where things can be more streamlined, right? So if I look at this Hyperledger platform, you can find out this more about Hyperledger in this on their web page, hyperledger.org. Now, Hyperledger serves as a greenhouse, I must say, that brings together, if you think of users, developers, vendors from many different sectors and marketplaces, okay? What is the goal? Goal is to learn, develop, and deploy enterprise level blockchain. That is the basic idea. So if I look at the Hyperledger greenhouse landscape, a lot of things you will find on their web page. And there are community, you can see you have development community who are working together to create different frameworks like Hyperledger Burrow, Hyperledger Fabric, Hyperledger Indy. So Hyperledger Fabric is permissioned, can help you create permission blockchain with channel support, whereas Hyperledger Indy is meant for creating decentralized identity management. There are many other frameworks and tools that are available. Hyperledger Composer, although is deprecated, and there are many things because blockchain is a fast developing, fast growing technology. Many things you will find are not there, which were earlier available 3 months or 4 months back. So coming to Hyperledger project design philosophy, the idea is to create projects which are satisfying these 5 design principles. First of all, you must have seen that Bitcoin or Ethereum blockchain require cryptocurrency exchange, right? So the first thing that comes to our mind in enterprise level blockchain, that why do we need cryptocurrency? So it is basically cryptocurrency agnostic. It doesn't require to have, one doesn't require to have a cryptocurrency in your wallet to operate on a blockchain network. Well, to make things life easy for developers and for application users, there are a lot of APIs which are available so that you can in a hassle-free environment, you can create your applications and you can run your applications, right? It is interoperable. What do we mean by that? Right now, if you think of Ethereum blockchain and Bitcoin blockchain, these are two different blockchains running with different cryptocurrency. Is it possible to, like it is possible to convert from Indian rupees to US dollar or euros? Is it possible that we operate, we can operate between the two networks and still we are able to make transactions between Bitcoin and Ethereum? Well, in Hyperledger Fabric network, we will be able to have interoperation, not necessarily of currency, but of various different transactions that can be made possible, that are possible, right? So it is interoperable, highly secure. Without that, nothing is possible in a decentralized environment. It has to be a secure environment. What is very interesting about this is it is modular. What do we mean by modular? We will see in a couple of minutes. Okay, so coming to Hyperledger Fabric, my dear friends, what is Hyperledger Fabric? It is designed for enterprise context. What does that mean? For enterprise level transactions, various constraints are there, right? If I wish to publish, say, some article as an academic person, all that I need is to submit it in a journal. That's all. I don't need permission from my dean academic or dean research or director. But in organizations like companies, which we have multinational companies, we may be having certain permissions that are required to publish your work as a patent, who will all be collaborators. All those things are required, right? So it is basically designed for enterprise context that delivers some key differentiating capabilities over other distributed ledgers. What is this? It is the first distributed ledger platform, Hyperledger Fabric, to support smart contracts written in general purpose programming languages like Java, Go, and Node.js, right? So it was the first distributed ledger platform where you don't require to learn Solidity or any other specific contract-oriented language. You can develop with your own programming skills in other languages like Java, Go, Python, and all those things. So second thing, it supports pluggable consensus protocols that enable the platform to be more effectively customized. For example, for some decision making, I may be requiring 3/4 majority, but for some other decision making and writing on the ledger, you may require only an authorized person to write. For example, in institutions like ours, Senate is the supreme authority on all academic matters. So there must be some peer, for example, dean academic, who can write on behalf of Senate that these are the modifications that have been made in the Senate manuals, right? But for making a decision that these modifications required to be made, you need maybe 51% majority of the Senate. So it supports pluggable consensus protocols that enable the platform to be more effectively customized to fit particular use cases and trust model, right? And it provides a modular and configurable architecture, delivering high degree of confidentiality. Suppose there are 3 companies who are working on designing an electric vehicle, and all these 3 companies specialize in different parts of an electric vehicle, right? Some company is only specializing in engines, the other companies are specializing in batteries, the third companies are specializing, say, in display system and so on and so forth. Now, how do we maintain the confidentiality or the privacy of information that is being floated between two peers of the same company or two peers of different companies who are thinking to develop some new technology? So the degree of confidentiality is required, resiliency, flexibility, and scalability. Scalability is something which is very important in an organizational setup. What I told before, that it does not require a native cryptocurrency. Basically, it's purely for business. So Hyperledger Fabric-based blockchain have these features. First of all, membership and identity management. How do we manage that this can be a member and this cannot be a member? And how do we, like for example, we have what is known as IIIT Council. IIIT Council have many members, member institutions, and each institution may be delegating 4 or 5 of its representative for taking part in IIIT Council meetings. So the member here is, say, IIIT, and identity management is done by the members and the membership management of the Hyperledger Fabric network. Secondly, privacy and confidentiality. Now, each, as I told you, that each member may be having some part of his personal data which may be private, and there can be some communication between two members that can be confidential, right? And then we also need to have efficient processing, because in enterprise blockchain, processing has to be very, throughput of the blocks should be of high, it should be high throughput. What is new that you are finding here is something which is known as chain code. Chain code is basically nothing but a smart contracts bundled in a bundle together and giving you an option to have an interface to deal with each smart contract. So chain code functionality, how do chain codes function? And then what is very important is modular design. Modular design means, as I told you, that there can be, say, 3 people in a company who are developing a new technology. So how do we ensure that there is a module that facilitates them to develop new technology, right? So if I hope this is clear to everybody what we are doing. If there's any question, please feel free in asking your questions. So now moving on to Hyperledger Fabric architecture, I seek your attention on how the Hyperledger Fabric network works. So there is a client application. The client application can be for any specific application, healthcare management, employee data management, or organ donation management, any application. Think of an external application. This client application will be dealing with the Hyperledger Fabric network. So in the Hyperledger Fabric network, there must be some admin who is maintaining the network. This admin team, so let's think that 2 organizations are planning to collaborate on developing certain decentralized application. So you have here, say, org1, organization 1, right? And org2, organization 2, who would like to develop this Hyperledger Fabric network, right? These 2 organizations are business organizations. So they plan that, okay, these should be the methods for different consensus. These will be the people who will be representing on my behalf and on your behalf. So org1 is suppose deputing that this is one admin person who can manage the network very well. So there is a peer who is deputed by org1 as admin peer. And suppose org2 deputes also another admin person, right? So these will be the admin people who will be managing the network. So these are the peers. Then org1 for say some business on certain account will be delegating another peer, right? So this will be peer for business 1 and another peer for business 1 I'm indicating from org1, right? Similarly, org2 will be also delegating its peers, peer business 2 and so on and so forth. So what I intend to say here is that there are certain people who will be associated with this fabric network, who will be making decisions and who will be evolving the different processes that will be then automated through the smart contracts. Okay, so there are certain peers in this network which are known as endorsement peers. There are certain peers who are known as committing peers. There are certain nodes or peers which are known as ordering peers. There is something which is known as a membership service of the Hyperledger Fabric network that gives recognition to these peers, each one of these peers. This membership service may take help from external certificate authority. For example, there are these two organizations, they will be certifying that they have these peers whom they are delegating. So, for example, I will be having my own identity card. That is an external certificate. Based on my identity card of IIIT DMJ, this Hyperledger Fabric network will issue me another identity card. So Fabric Certificate Authority in that case will be issuing another identity card to me. That means my ID as a peer, what will be my role in the entire network as a peer? That is what is defined by the Fabric Certificate Authority. Is that clear to you all? Please write yes in case this is clear. If you have understood, please write yes on the chat box so that I can go ahead. Is there any questions here? Okay, thank you. Thank you. So I go ahead with the next slide. Thank you. Thank you. I go ahead with the next slide then. So now, let's see. Certificate authority, I told you that can be external or internal. And each participating organization can have its own certificate authority for different roles also. The same organization can have different certificate authorities. So certificate authority can be, for example, for students, Dean Student is the certificate authority. For a faculty, Dean Faculty is the certificate authority. For many other things, registrar could be certificate authority for IIIT DMJ, right? And then there's something called membership services that I told you that this service takes services of CA to provide a unique ID to every participant of its organization in the network. Client application, there can be one or more organizations that may be participating in the same network for some application. If it is purely for IIIT DMJ, then there's only one organization and several certificate authorities. If it is IIIT DM Jabalpur, IIIT DM Kanchipuram, IIIT-DM Kurnool, then there can be many certificate authorities. So the client application can be sharing and updating information on the development of some product jointly by multiple organizations. Then in that case, there can be multiple, many organizations who join this. Well, this is something which is important to know, that client application can be implemented in any language. There is a good set of SDKs, software development kits, to facilitate client application do its business on Hyperledger Fabric network. And these SDKs are available in Node.js, Java, and Go right now. For Python, they are developing. Okay, so now let us come to peers and client application interaction. What are peers? Peers are fundamental elements of the network. By peer, I mean a person, not only a person, but a software installed on his computer. So peer is basically a node, which is, and there is somebody who is represented by that computer, right? For example, Dean Academic is represented as a peer on a computer. So peers are fundamental elements of network. They host ledgers and chain codes, precisely smart contracts. They're responsible for endorsing, committing, and ordering transaction. This is very important. I seek your attention here that every single peer is responsible for something, for endorsing some transaction, for committing those transactions, and ordering those transactions, right? Chain codes and ledgers are used to encapsulate the shared processes and shared information in a network, respectively. So what does that mean? That chain code basically gives you every single process that is to be performed is automated through a consensus that has already been made amongst all participating organizations. And then those processes have been automated. And then those ledgers will be containing the transactions that are there. So a peer can host more than one ledger, depending on the requirement. For example, one peer can take part in 2 different channels having different ledgers. What is a channel then? Let me explain to you. So there is a peer who is, for example, a faculty also, and Dean Academic as well. So if a peer is serving as a faculty, he will be responsible for grading students. If he is in addition Dean Academic, then he will be responsible for managing the grades and declaring the results of students. So what is a channel? Channel basically is nothing but a private subnetwork for communication between 2 or more network members. So Dean Academic may be working will be collaborating with associate dean, with assistant registrar or registrar of that institution to prepare results. So for that, faculty are not required. They have already submitted their grades or marks. Faculty members are not required. Students are not required. This channel has to have a communication between dean, associate dean, registrar, and other office assistants who will be preparing and verifying results and finally declaring results. So for them, there has to be a small communication channel which does not allow others to intrude or to write or modify the data, right? So for confidential and private transactions, channels are created in Hyperledger Fabric. I request you to just review Ethereum network or the Bitcoin network, where there was no channel, separate channel. If there is a network, every single participant will be receiving all the transactions information of any transaction proposal. Whereas in Hyperledger Fabric, which is an enterprise level blockchain network, gives you enterprise blockchain network, you have this specific special facility where channels can be created, right? So in public blockchains, you have one single network, whereas in enterprise level permissioned blockchains, we can create channels for communication and transactions. So two companies may collaborate to submit a product's price to other companies in the network. That can be one example. Now, let me come to specific roles of peers. Okay. So peers, as I have told you, are fundamental units of Hyperledger Fabric network. So peers are nodes performing different tasks. There are three different types of peers. One is a committing peer. What does that mean? They commit transactions basically, right? So because they commit transaction, they must be validating the transaction. So they hold ledgers and states. States means the network state. What is the current state of the network? Who is holding, say, 500, who is holding the complete updated CNET manual, right? That is what is the current state, right? And they hold ledger. That means what has already been written, whatever transactions have already been completed, that ledger of those transactions is also there. They may hold chain codes, but they may not hold chain codes as well, right? So it's not necessary that they hold chain codes. That means they're not worried about whether the conditions for some consensus are met or not. They only need to know that these states need to be changed. And for changing the states of the network, state of the network, every single transaction they need to validate, right? So by this, I mean that the chain code, they may or may not be holding. But endorsing peers, they actually receive transaction for endorsement. What does that mean? There is a transaction proposal. And the transaction proposal is between, say, two companies. Other companies have to also agree on that transaction proposal, right? For example, I can say that I'm buying 300 computers, somebody is selling 300 computers, and other companies should agree that, okay, all the conditions are met. This was the person who was lowest bidder. This person was satisfying all the terms and conditions for purchase or for selling the computer, and the terms and conditions for purchase of computers were clearly defined by the purchasing company, and so on and so forth. So these endorsements are required to be made by endorsing peer. They may endorse or deny transactions, but they must hold chain codes, because chain codes are precisely those rules that define what conditions are needed for endorsement of a transaction proposal. Ordering peers. Who are ordering peers? They actually approve inclusion of transaction blocks. I hope you remember blockchain. In the blockchain, what is happening? A chain is linking the blocks, and these blocks are containing transactions. These blocks have headers. These block headers are linked with the transactions of recorded in the previous block. This block header is again linked with the transactions recorded in the previous block, so that there's no tampering that can be done on these block, and that makes them immutable. So ordering service peer, they approve inclusion of any transaction blocks and order them. They notify the peer. So unlike public blockchains, where people are competing with each other, doing mining operations, applying different methods of consensus, like yesterday you studied, you saw proof of work, proof of stake, proof of authority, many different types of proofs of mining operations, many different types of consensus algorithms were existing. So here, it is the job of ordering peers to order. So from each organization, there can be some ordering peers who will then have a consensus to order a block in a specific order. Now, here it is not necessary that the order will be the same as what has been received first. For example, for updating a CNET manual, I might have updated section 1 of CNET manual. Someone else has updated section 2 of CNET manual, but the order, it is not necessary that CNET section 1 and section 2, if they are updated at different points of time, their ordering will remain section 1 and section 2. Section 2 might have been completed before, but section 1 might have been completed later. But here the ordering peers will decide that section 1 has to be recorded prior to section 2 in the CNET manual. Right, so they do not keep here, so they define what will be the ordering, right, of writing the block. They notify the peers whenever the blocks have been made, ordered, they notify the peers. But remember that they need not keep copies of the chain code or ledger, because for them, it is only ordering that is required. I hope this is clear to everybody. So through SDK, a client application interacts with peer. Any client application will interact with peers. Applications can execute chain codes to query or update a ledger. So query means, for example, I'm making a query that how many computers are needed in each section of my institute. So that is simply a query, right? For updating, what I need to know is not only changing the state of the network, but also writing those transactions in the blockchain. So in case of a query, application connects to peers and invokes a chain code to query a ledger. Remember that even to query something, you need to invoke a chain code. Peers invoke the chain code to generate the query results. And application receives the query results and process is completed. That is how it happens. In case of updating, if it is just a query, you don't require to update the ledgers. So the process is completed. In case of transaction, the ledgers will be updated. Okay. Now, what is pluggable service? I told you that this Hyperledger Fabric gives us an option of pluggable services. So what is a pluggable service? So basically, there are several pluggable services, including ordering service, that establishes consensus on the order of transaction and then broadcast blocks to peers. One thing I forgot to mention, I'll go back. What happens? I'll go back to this. So this figure, that what happens that whenever a transaction proposal is made by the software development, by the client application, it so happens that suppose there is a update proposal. So this will go update proposal will be sent to the endorsing peers. Endorsing peers will look at the proposal. They will find out whether the proposal is in order. The proposal can be accepted for transaction update, for transaction, and it can be recorded on the blockchain. They will be giving their responses, right? So suppose there are 5 endorsers, 5 endorsing peers, right? 3 of them respond in affirmative, 1 of them responds in, say, negative, and the 5th one is silent, has not responded, right? Then the client, and so all of them will be sending back their responses, right? So 3 have responded positively, 1 has responded negatively, 1 is silent. So this client application will check what is the endorsement policy. What is the endorsement policy, right? So client application will check. And if the endorsement policy says that any 3 out of 5 are sufficient to complete, to endorse a transaction proposal, then it will be sending the transaction proposal to the ordering services. That means it has passed through the endorsement policy, and therefore transaction can be, sorry, what has happened? So therefore transaction can be put in the block, in a blockchain, in the blockchain, in the ledger. Is that clear to you? So 3 out of 5 is the required endorsement policy for this proposal. Now, if suppose only 2 have said yes, and 2 have only said yes, and 1 has said no, and 1 is silent, then client application will not be sending this to the ordering services. Mind you, the client services client application is responsible for checking whether the endorsement policy is met or not. The conditions of the endorsement policy are met or not. Accordingly, it will be forwarding the transaction to the ordering services for registering in a block. Now, ordering services in its turn will be sending the transaction to committing peers who will be verifying and validating the transactions, and then they will be committing those transactions on the blockchain. And then the event will be generated that will update the state of the network. So even if the client application has forgotten and or has ignored that the endorsement policy is satisfied or not, it will be the committers or committing peers who will be again checking whether the endorsement policy is satisfied or not before the event is generated or before they commit the transaction to the block. So now you can see that there is no proof of work required, no proof of stake required, not long calculations required to do the transaction updation. And therefore, the throughput of such enterprise blockchain is very high as compared to the other services, other decentralized application where we have public blockchains. So I was telling about pluggable ordering services that establishes consensus on the order of transaction and then broadcast blocks to the peers. Is that clear to you now? What does that mean? So ordering services may be having a different consensus mechanism that may be changed later Therefore, it is known as a pluggable service. So for some part of the application, you can plug in a different ordering service consensus mechanism. For another part of the application, I may be requiring a different consensus mechanism, right? Therefore, this is known as a pluggable. Similarly, I will have a pluggable membership service provider. This is responsible for associating entities in the network with cryptographic identities. Remember that every single person will have cryptographic identities. As you know, that every single person will have his own digital signature, his own private and public key pair that is used in the to maintain the privacy as well as the confidentiality in the network. There is an optional peer-to-peer gossip service that disseminates the block's output by ordering service to other peers as well. Now, coming to smart contracts or chain code, you can call them here in the context of Hyperledger Fabric network that run within a container environment, that is Docker, for isolation. So one requires smart contracts to remain safe, secure. Therefore, you have a Docker containers available in where we run those smart contracts within the container environment. They can be written in standard programming languages, but do not have direct access to the ledger state, remember. The ledger can be configured to support a variety of DBMS. I mean, some of you were talking about databases yesterday. So here, it gives you an opportunity to have your own method of devising your own databases so that things become easy for people who will be doing business with those databases. So similarly, we can have a pluggable endorsement and validation policy. It can be independently configured for each application. So there can be, think of an organization, there can be many applications within an organization. For example, at an institute like ours, there are many applications, student applications where student services are there, services to the students. Then there is an academic affairs section, which will have all applications related to the studies of the student. Then there can be HR application where employees management will be done. So an application can have different parts, and each part may have a different kind of endorsement policy, ordering policy, membership policy. Accordingly, it gives you, Hyperledger Fabric gives you these kinds of facilities. What is new in this smart contract is that we first execute a transaction, check its correctness, thereby endorsing it. All smart contracts will be written to execute these policies, right? To implement all those policies which have been agreed upon by institutions or organizations. Order transactions via a pluggable consensus protocol, and validate transactions against an application-specific endorsement policy before committing them to ledger. What is very interesting here is that this execute, order, validate forms the very basic of the entire consensus mechanism in the blockchain, a Hyperledger blockchain network. So blockchain application in Fabric network, if I look at it, any blockchain application will have two parts. One is chain code or smart contract like we have, right? Think about Ethereum blockchain. You have smart contracts, right? To do the business, to write the business logic, right? Which is deployed and executed inside the Hyperledger Fabric network or simply Fabric network. And then we have a client application that uses the chain code deployed on the Fabric network. So similarly, like in Solidity language, you wrote smart contracts, but for running those applications, you need some front end that integrates the front end with back end. So Prashant told you how smart contracts can be deployed. Samir also gave you an idea how smart contracts can be deployed in the network and how a user can interact with those smart contracts. So let us begin with an example, which is a slightly old example of in Hyperledger Fabric network known as FabCar. Fabric car. So an application that is developed for car dealers and probable buyers, right? So let's consider these fab car application where we have each car, its make, the model, the color, and who is the owner, right? Similarly, car ID 2, again, make, model, color, and who is the owner, and so on and so forth. So suppose these are different owners, they can be companies of this car, right? So we have every car has got a car identifier, make, model, color, and owner, right? So this is a data for each car. So ledger structure, recall that any ledger, think of any ledger, whether it's a bank ledger, library ledger, a ledger contains what? The current state of business as a journal of transactions. So let's consider, for example, library accession register. So in library accession register, whatever books have come, they will be recorded with their classification numbers, accession numbers, when they arrived, what is their current state, whether they are still in the library or stolen or deprecated or something because of maybe something like whatever may be the reason, right? So the current state of business as a journal of transaction. It stores facts about business objects. Here business objects are library books, right? So those are the facts. What is the date of arrival? What is the current state and all those things? And it is immutable. What is important here is that it is immutable. So facts or change of state of a business object can only be added, but it cannot be retrospectively like modified or changed. Just like your bank register, your account register, you know that your account in bank, if you are withdrawing money, if you are depositing money, whatever, every single event is only appended. There's nothing that can be modified on a back date, right? So similarly, Hyperledger Fabric, a ledger has two distinct components. One is a world state. It's a key value pair of the current state of the set of ledger states. It is flexible. It is very flexible, this world state. Its states can be added, updated, deleted. But then there is a blockchain. You know that it's a transaction log that records all the changes that have been resulted in the current value of the world state. So transaction log means it cannot be changed. Every single thing will be recorded on this blockchain, right? So for example, owner yesterday was someone else of a car, and today the owner is someone else, but then it cannot be omitted that the previous owner was such and such fellow from date 1 to date 2, right? That is what is written in the blockchain, right? So any questions here up to here? Each of these represents a set of facts about business objects. If you have any questions, please feel free in asking. Else, I will proceed, or we can have a small break so that you understand what exactly we have covered till this period, and then we will go ahead with the fabric ledger structure. Any questions you have? No questions? Okay, so I go ahead. So I seek your attention on the type, what is a ledger in here, right? So a ledger, basically in a Hyperledger Fabric network, is a blockchain B and a world state. As you can see here, you have a blockchain B and a world state. So B determines world state. Or in other words, we can say that world state is derived from blockchain B. So the ledger here consists of one, what is the current state, but that current state is changed only when the transactions are recorded in a blockchain. So L comprises B and W, B determines W, and accordingly W is changed, right? The world state is changed. That is what happens in the Hyperledger Fabric network. So so if I look at the world state, for example, car key is equal to car, value is equal to Audi, like value, this key, primary key here is car, its value is Audi version 0, right? So it is telling me a ledger state with key is equal to K. It contains a set of facts expressed as a simple value V. The state is version 0, right? This is how. I can also have key is equal to car 2, but now value is not that simple. Value here is type is BMW, color is red, owner is Jane, version 0, right? So again, you have a ledger state with key is equal to K, but it contains a rich set of facts expressed as a set of key value pairs where the state is again at version 0. So what I intend to tell you right now, that there can be two different ways of having this. So world state is basically implemented as a database, but you know that in the database, key value pairs are very often commonly used. So database provides a rich set of operations for efficient storage and retrieval of states. So operations here, sorry. All right. So ledger states can have simple or compound values, as I said. There's one option like level DB. We call it level DB for ledger states as simple key value pairs here. So level DB database is what? It's a closely co-located with network node and is embedded within the same operating system process. Remember that you don't require a different operating system process. So it is associated with the same operating system process as here. But in case of CouchDB, when the ledger states are structured here, the ledger structure, as I told you that in case of car2, you had a different ledger state. So this is a rich queries and update for complex data types, and they're very common in business transactions. So CouchDB runs on a separate operating system process, but there's a one-to-one correspondence between a peer node and a CouchDB instance, remember. So in this FabCar example, that is although there in the Hyperledger Fabric tutorial, This app creates a set of 10 cars, each with unique identity with color, make, model, and owner. But the ledger shows its state after the first 4 car instances have been created. So you can see here, there are 4 keys and the corresponding values. This has been there. This is a Genesis block. After the Genesis block is created, these 4 transactions have these 4 car instances have been created, and these have been recorded in this. So that is the blockchain, and then accordingly the world state is this, right? Tomorrow the owner changes, the world state will change. Owner and the car color changes, the world state will change. But then everything will be accordingly recorded here. Right? So we have discussed about channels. So in Hyperledger Fabric Network, 2 or more nodes can create a private channel. This private channel can be for transaction between them. So each channel has a completely separate ledger, remember. Each channel will have a separate ledger. There can be a number of channels in a blockchain Hyperledger Fabric network. Each will have its own ledger. And each channel accordingly, because it has a separate ledger, it will have its separate world state. So it is possible for applications and smart contracts to communicate between channels, remember. That is what we call it interoperable as well. So that ledger information can be accessed and shared between them, right? So for example, suppose I own a car, and then I am making a deal with another person for change of ownership of car. So there is a channel that will be created between these 2 persons, and suppose the second person pays in installment. So first installment, he makes payment. Second installment, the third installment, when he makes, the car ownership changes. But this first installment information about first, second, and third installment, people need not know. Other members are not worried about how many installments are paid. They are only worried about the changes in the ownership of the car, right? So this intermediate communication and transactions that have taken place between 2 people, one doesn't need to keep a record of all those in the entire network. That can be between them as a mutual consent between these 2 people. And therefore, each channel has a completely separate ledger. Now, as I told you, consensus mechanism in Hyperledger Fabric network is altogether different. The entire transaction flow in Hyperledger Fabric defines the consensus mechanism. So can somebody tell what is the consensus mechanism in Hyperledger Fabric network? If you raise your hand, then maybe I can unmute you. Anybody who would like to tell what is the consensus mechanism in Hyperledger Fabric network? Okay, so Neetu Sharma has raised her hand. Yes, Neetu, please tell.
Yeah, hello, ma'am. In Hyperledger Fabric, the consensus mechanism basically we follow either the solo consensus mechanism for development purpose, and and we can also use Kafka and Raft consensus mechanism that uses leader follower mechanism to reach the consensus.
Thank you, Neetu. But I was not asking that. I'm asking about writing. Finally, how do you write? How do you change how do you add any transaction in the network, right? How do you add any transaction in the network?
That one is done by ordering service that sequences the transactions. First of all, endorser simulate the transaction as per the chain code policies, and then after that transactions are recorded in blocks and sequenced by the ordering service, and then that block is broadcasted to all the network members, and after their validation the blocks are added into their ledgers. So I think that.
Yeah, good. Thank you. In fact, it is the entire complete cycle that is performed. So first, the client application will send the transaction proposal. That will be endorsed by endorsing peer. That will be sent back to the client application. Client application will again further forward it to the ordering service. Ordering service will further send it to validators. Validators will validate and then commit the transaction, and then ordering services will order them, and the event will be generated. It will be broadcast to all. So the consensus mechanism is this only here, that what we will be doing is the whole transaction flow is your part of consensus mechanism. So the transaction flow contains endorsement policy that requires to be satisfied, ordering consensus that requires to be satisfied, validation and verification of each transaction that requires to be satisfied, so that commitment people can say that, okay, this can be committed. So all this is required, and then that is what is Hyperledger Fabric consensus. So in a nutshell, we can say that the consensus mechanism is defined as the full circle verification of the correctness of a set of transactions comprising a block. That is what is a consensus mechanism. So unlike the consensus mechanisms which are there in public blockchain, this is a kind of deterministic consensus. What do we mean by this? So a permissionless blockchain network, any node can participate in consensus process, as we know, right? Anybody can participate. So like you can start mining a block. Nobody can stop you. You can also be, in case of proof of stake, you can be a validator. And from amongst the validator, there is a block writer, right? In case of Ethereum proof of stake consensus mechanism. So in a permissionless blockchain network, any node can participate in the consensus process. So in the associated distributed ledger, transactions are ordered and bundled accordingly into block, right? So what happens? Suppose there are, let me take an example. So suppose there are certain nodes who are taking part, right? These are nodes, and in a consensus mechanism, suppose this person has proposed a block of transaction, right? Now, ideally, all others should be, or at least a majority of them nodes should be giving consensus that, okay, we validate that this block can be added. But maybe that these three nodes remain idle. So you have only 4 nodes which will be giving consensus to, which will be validating that, okay, these blocks are good. I mean, this block can be written. So what happens that probably these 3 nodes are remaining idle, and therefore it may happen that probably you are getting consensus with certain degree of probability. So I say that probabilistic consensus mechanism ensures that there is a high probability of ledger's consistency, right? That this ledger is consistent. Whereas, so what does that mean? The order of every block of transaction is decided with a very high degree of probability. That is what is a probabilistic consensus mechanism. But these consensus mechanisms, you know, that they often result in divergent ledgers known as forks due to different views on accepted order of transaction. So let me take an example that some minor one has, in case of say proof of work, minor one has created a block, right? And he is claiming that, that these many transactions, T1, T2, T5, T7, these should be kept in my block, right? Another minor almost at the same time, right? Minor at the same time is also coming up with another block where it has T1, T2, T3, T4, maybe, right? And suppose this has claimed at timestamp T1, this has claimed at timestamp T1 plus delta, very small time. Because of the network delays and all those things, it might have happened that some network participants have received this block first, and some other network participants have received this block first. So those validators will start validating the transaction T1, T2, T3, T4 for minor 2. And so suppose these are validators V1, V2, V3, V4, V5, these V4 and V5, these 5 validators are all started, they have started validating the block created by minor 2. And other validators, say V6, V7, V, and so on and so forth, they are validating the block, this block. And so the claim can be done, but once this is validated, then only the block will be created. So when the block is created, right, when the block is created, there are 2 claimants, minor one who is created block 1, and another minor 2 who has created block 2, right, block 2. So which block to be added to the network? So this is a blockchain where the previous block was this is the next block, right? Now the next block that will come may be added to this or to this, and this will keep on doing this. And ultimately one of the longest chain will win, but there will be forks in the blockchain. That is what I wanted to explain you. So what I mean to say here is that there is very much likely that there are divergent ledgers known as forks due to different views on the accepted order of transactions. But in the deterministic consensus mechanism, this is eliminated because business people would like to have these companies like IBM or Mitsubishi, they would not like to keep something kept on pending for a long time. So Hyperledger Fabric provides a deterministic consensus model through its ordering services. As a result, the probability of a fork creation in the ledger is eliminated. Now, an ordering peer performs transaction ordering as per the ordering rules, which along with other ordering peers forms the ordering service. Now, so if a block is validated by peers as generated by the ordering services, it is guaranteed to be final and correct. There's no chance that a fork will be created, right? So different roles by different types of peers provide the advantage of performance as well as scalability. Some people have discussed in the past about blockchain scalability issues. In public blockchain, scalability has been a great issue, right? So how do we eliminate the difficulties that are there in public blockchain by having this deterministic kind of consensus mechanism. So Neetu Sharma was telling about some Kafka and Raft and all those things. Let me tell you here, ordering service consensus, a bit about ordering services consensus. There are different ways of achieving consensus on the strict ordering of transaction between ordering services nodes, right? There different types of consensus could be there, and that is why this is known as a pluggable consensus method that we use in Hyperledger Fabric. So Hyperledger Fabric currently follows Raft ordering services to reach consensus. I'm telling about ordering service because there are several ordering peers from different organizations. They may be competing with each other that let this block be kept first prior to the other block, but then there has to be a consensus among them. So earlier consensus mechanism that was used by Hyperledger Fabric included Solo, which was used for only test networks, Kafka, which is quite similar to Raft, and these are the ordering services which were there. So let me explain a little bit, very sketchy understanding of what is Kafka. Basically, Kafka is a leader and follower load configuration. That this Kafka exists since the time of distributed networks, when distributed networks were introduced. So Kafka is a method of arriving at a consensus to a node, to a network state by using a leader and follower node configuration. So Kafka utilizes a zookeeper ensemble for achieving consensus. What is a leader and follower? From among all the ordering peers, one is selected as a leader. How is one selected as a leader? For example, in a community, out of, say, let's consider an apartment where there are 100 families which are residing. Out of those 100 families, suppose some 10 persons volunteer to manage the safety and security of the complete apartment, right? Now, these 10 people have volunteered. From among these 10 people, who will be the leader is decided by some election method or decided by some consensus method. And this can be randomly selected, or it can happen that the same person is selected every time. So in leader and follower, this does not happen actually. People are selected randomly in a pseudo-random way so that everybody gets a chance as a leader and others become followers. Normally this is what happens, right? So what is zookeeper? I'm saying here that Kafka utilizes a zookeeper ensemble for achieving consensus. So what is zookeeper ensemble? Basically, a zookeeper services to be active, there must be a majority of non-failing machines that can communicate with each other, right? So it's not like this that we are all sitting together. Many of you remain idle, say that my network was poor. In case of right now, our own network is showing poor response. So that is the reason I have kept my video off. So one is required to have non-failing machines that can communicate with each other, and to create a deployment that can tolerate the failure of F machines, you should count on deploying 2F+1 machines so that majority of them do not fail, right? That is what is written in Zookeeper Administrator's Guide. So Kafka is a consensus mechanism where by some kind of round robin method or any other method, a leader is selected and some followers, the remaining nodes become followers. So In Kafka, only the leader does the ordering and only the in-sync replicas can be voted as leaders. What does that mean? That there are 10 volunteers, I told, they are having equal capacity, they are having equal capabilities and efficiency. So these are in sync and these are all up and running. These 10 machines are up and running. Then one of them is voted as leader. So this provides a crash fault tolerance. Even if there are F machines that fail, up to F machines that fail, we can tolerate, and the finality is achieved very quickly in a matter of few seconds. That is what is Kafka. While Kafka is a crash fault tolerant, it is not Byzantine fault tolerant. So what is the difference between crash fault tolerance and Byzantine? Because Byzantine fault tolerance, as you saw yesterday and day before, it prevents the system from reaching agreement in case of malicious or faulty nodes. That is what is required. Give me a minute. So I hope this is clear that ordering service also has a specific method of having consensus. So Raft is the most recent ordering service implementation introduced with version 1.4.1 of Hyperledger Fabric. You can find it in Hyperledger Fabric documents recently done. So Raft is also a crash fault tolerance tolerant ordering service based on an implementation of Raft protocol. So it's very similar to Kafka. It also follows a leader and follower method where a leader node is elected per channel, right? For each channel, you have a ledger. If you remember, each channel has its own ledger. So a leader is elected in each channel and its decisions are replicated by followers. And Raft ordering services are envisioned. People, I mean, we have seen that in documentation of Hyperledger Fabric that easy to set up and manage than Kafka-based ordering services. That is the reason they recommend. I'm not saying that you can use, if suppose you're developing a Hyperledger Fabric-based network-based application, it's not necessary or mandatory that you use Raft. You can use your own ordering services consensus. So Raft is designed to allow different organizations to contribute nodes to a distributed ordering services. So that is the reason Raft and Kafka are in use, and Raft is recently done. So now coming back to transaction flow diagram for a visual representation of consensus mechanism. So this is SDK, right? You have a transaction execution proposal. Suppose there are 3 endorsing peers, right? These 3 endorsing peers are there. So first of all, whenever the transaction proposal comes, they will verify signature for whether these signatures are valid or not, whether the transaction proposal has valid signatures. If it is not, then transaction is aborted. And then if it is yes, then a smart contract is executed by endorsing peers. And then the responses are sent. So SDK verifies against endorsement policy. SDK verifies whether the endorsement policy is satisfied or not. If it is yes, it sends it to ordering services. Ordering services will prepare blocks and will send it to committing peers. Committing peers will again verify everything, and then they will be committing it to the ledger. And then the event will be triggered. During the same time event is triggered, every peer will be updating the things in her nodes, right? So this is how the complete transaction flow diagram, complete transaction flow comes from the transaction proposals to written on the finally written on the ledger, right? So in summary, Hyperledger Fabric provides a very secure and efficient distributed ledger technology for enterprise level modular blockchain architecture. Remember, it's modular. Apart from network security, first thing which is very important is that it is a scalable, privacy preserving. Why? Because you can have options for channels. Your membership service provider of the Fabric network can only fetch information that is very much essential for giving you the certificate of from this network. So all other personal data can be neglected. So it's privacy preserving. And for all business applications, because of pluggable consensus, because of modularity, because of scalability, it is considered to be one of the very apt network framework platform for having having decentralized applications. So main components of Fabric architecture include client applications, certificate authority, membership service providers, and peers in the network, right? So basically it consists of organizations. There can be car companies, there can be mobile companies, there can be people who are, for example, contractors, civil contractors, electrical contractors, and government organizations who will be getting the work done. This can be this network as well. So each peer has a unique role and hence privileges to write on the database. Peers can be ordering peers, endorsing peers, or committing peers. They can have multiple roles as well. Like, as I told you that as a faculty, I have a role to submit grades, but as a dean faculty, I can have multiple roles, other roles as well, right? So transaction flow consists of endorse, order, validate, and commit. An endorsement policy in a channel depends on how all participants or how all participating organizations decide about what should be the endorsement policy. For example, it can be 51% majority voting, or it can be 3/4 majority, or it can be only leaders, and whatever the leader decides. So depending upon what is the consensus mechanism, like I told you in the case of ordering services, it is a leader and follower consensus mechanism that is followed. Whereas in endorsement policy, by endorsing peers, it could be just 3/4 majority or any other majority that is followed. So ordering services right now is using a raft protocol for consensus, but it's only a recommendation, not a mandatory thing. I have taken most of the text in the slide from the official website of Hyperledger Fabric Network, and I would like to stop share here and would like to show you the one thing. Just give me a minute. So I request you to please go through this Hyperledger Foundation page, and here you can see that learn. Here you can see case studies, white papers, research even. Use, what is very important here is use tutorials. Tutorials are written, some of them are a little old, but they are excellently, tutorials are excellent. Let me come to Hyperledger Fabric here. You can see getting started, tutorials, samples, build your own NFT with Hyperledger Fabric network. So NFT, I hope you know, it's a non-fungible tokens. So tutorials are something which are very important for learning Hyperledger Fabric. So you can see that if you use the latest tutorial, the key concepts include introduction, Hyperledger Fabric model, how networks are structured, identity, membership, service provider policies, every single thing you can find here. So I think that you have sufficient material here to do, and tomorrow we are going to have our first lab sessions or demonstration sessions on this. And I am requesting my student Samir Jain, who is working on blockchain technologies for healthcare systems. So I request you to please tell the participants if any preparations are required for the lab. Thank you all. If you have any questions, please feel free in asking on the chat box or raise your hand. Samir, are you there? Let me see if Samir is there. Samir must have joined. Yeah, I'm giving, Neha, please make Samir a co-host. Yeah, he's co-host now. Samir, over to you. Thank you.
Yes, ma'am. Thank you so much, ma'am. Okay. Hello, everyone. So tomorrow we are going to have a lab session on Hyperledger Fabric-based network. So let me share my screen first. Yeah. So tomorrow we will be doing something that is a test network. We will be running in our own system, and we'll see how a Hyperledger Fabric environment seems like, and how we can execute some of the transactions in that network. So for that, just ma'am has shown, we have to go to the Hyperledger Fabric web page. So you have to go to this hyperledger.org. So in this, by default, they're taking Fabric. So in hyperledger.org, you have to go to this build your first network. So there, actually, there are certain things Hyperledger needs when you want to run the network in your own system. So first thing is that if you are using a Windows system, so there are certain things like certain softwares that they need to run, and they have a different specification for each kind of environment. Like for Mac, they have a different environment. For Windows
You mean
systems.
to say that if suppose tomorrow they want to run the network and build the test network with you, some software need to be installed or something like that?
Yes, ma'am.
Yeah,
Yes,
that's
ma'am. Yes,
what.
ma'am. So there are
Thank you.
some prerequisites that are needed. So when you are going to this link, getting started install, here so they are saying that there are some prerequisites for softwares. So we have to go inside this, and you can check it out if you are running a Mac PC. So the prerequisites are already given over here. So if you are running Mac, then you should have Homebrew, Git, curl, Docker. So Docker is basically one of the important, most important thing that you need, because there'll be, you know, there'll be containers. Actually, they'll be called up when you are installing Hyperledger Fabric in your system. So when we are calling the containers actually are the virtual machines. You'll think of a machine that are running in your system. So Docker will call the images of those containers, and those containers will be running. So there, while you are having Docker in your machine, there can be more than one machines that are running in the form of containers in your hand. So actually, because we'll be using Docker, we'll be using Hyperledger Fabric. So we'll be having some organizations, some orderer, peers will be there. So for each of them, because the behavior is different for each of them, so there will be a different container for them. Like for one container is running only for the peer, one container is running for the orderer, one container is running for organization. So there will be more than one containers that will be running. So to manage those things, Docker will be responsible. Okay. So you need.
So, yeah, that's what I want to know. So they have to run like all these commands if they wish to be synchronous with your
Yes, ma'am. Yes, ma'am.
session
Actually,
tomorrow.
yes,
So
ma'am. Yes,
all
ma'am.
in this page, what all is required, if you can
Yeah,
tell them.
yeah, 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 yeah.
Then tomorrow you can explain in detail, uh, what is needed, prerequisite for tomorrow's session, if you want to run your network and build your application.
Yeah, yeah, yeah.
Yeah.
So actually, I'm just going to the Windows because most of the users are, Windows users. So for Windows, you need to have WSL2. So the people who are running Windows 10, and default is there. WSL2 is a default one. But the people who are running older version of Windows, like Windows 7 or Windows 8, so please just find it out from the Windows website that the WSL2, how to enable WSL2 or how to install WSL2 in your machine. So WSL2 is basically a Windows subsystem for Linux. So what we will do is we will call a Linux. You can just go here. You can find Microsoft Store. So either installing directly all these things in your machine, we will what we will do. We will install a Linux subsystem in our Windows machine. So you have to search for. Here you have to search. So you can type Ubuntu over here. So Ubuntu is one of the Linux platform. So we'll have Ubuntu 20. So you can have Ubuntu 20.04.6 LTS. This one, because this is already installed in my system right now. So I have done all the tests on this Ubuntu 20.04. So you can directly go to this Ubuntu 20.04 if you are a Windows user, and then you can install this Ubuntu first. And after installing this Ubuntu, you need there are no steps that are needed right now to install the Ubuntu. Just have to get will be there. So there will be in my machine it is showing open because it is already installed. If you want to install Hyperledger Fabric in your machine, you have to go to this Microsoft Store, you have to search for Ubuntu, and there will be one GET option, get, and it is free of cost. You need not pay anything. So you can press get, and then this Ubuntu will be installed in your machine. After installation, it will ask from you that what is the username and password you want to give to this new environment. So you just pass those things to whatever it is required from their side, from Ubuntu side. So you can give it and you can create your username and password. After that, you'll have Ubuntu like this, Ubuntu. So this will be the Windows subsystem for Linux. Like you are having a Linux machine that is running over Windows. Okay, just like those things. Uh, uh, what I can say is, mm, you have seen virtual machines like VM Manager, VMware is there. So Hyper-V is there. So those things you'll like. There, it is just very closer to those things. So, but in Windows, it is very much compatible. So please use this only. It is my recommendation. Now, uh, after that, you are having you just have Windows this Ubuntu 20.04 as a WSL thing. After that, you have to install Docker. So you have to install Docker not in this WSL, but you have to install Docker separately. So you can search for. So you can search for Docker desktop. So this is the Docker desktop. Okay, so this is documentation for Docker desktop. You need to go to this one, the first one. So products. Under products, you'll get the Docker desktop application in the form of executable file. So you can download Docker desktop. After downloading Docker desktop, you have to open this. So when you open the Docker, you have to enable you have to enable WSL that should be linked to the Docker. Okay, so Docker will identify and there is WSL in your machine, and you can add that WSL to Docker desktop so that it will be able to communicate. The WSL will be able to communicate with Docker desktop. Okay, so why Docker and why WSL? So in WSL, you will be installing Hyperledger Fabric, but Hyperledger needs containers. Those containers will be in the Docker desktop. Okay. So this is Docker desktop application that is running right now. After installing it, you will find this page. And then what you have to do is you have to go to this settings. Okay. So there are containers because right now there are no containers that are running. So it is not showing those containers, but there are some images. So where do these images came from? So these came from when I have installed this Hyperledger Fabric samples. Okay, so when I've installed these things, I've got these images. So what you have to do is you will be having no containers, no images. I'll tell you how to install, and then you'll have those all those things. So here, after installation of Docker, you'll find one thing that is resources. This option. This option, there is one last option that is WSL integration. So under WSL integration, it will be disabled like this thing. This it would be disabled because you are doing this for very first time. So you have to enable it like this. Okay. So by default, it will be disabled. You have to enable it, and then you have to apply and restart. Okay. So two things you have gone through. First thing is what you have installed WSL. This one. Second thing, the Docker desktop, and you have enabled the integration. Okay. After that, you need to install Golang. So install Golang in
So
WSL.
Poonam, you can watch the video again. Poonam is saying go slow.
Okay, yeah. I'm just giving you just how you can do that, but no steps. I'm showing you how to because it will take more than
Yes, it will
like
take time, and therefore we are requesting you to do it yourself before we come for the session tomorrow, so that right. So please, we are not making any WhatsApp group. There's somebody who is making a WhatsApp group. Let him manage that. We are not making any WhatsApp group, please. We are sharing with you video links. That is already shared. So please use that link. Okay.
so. So what you have to do is third thing is Golang because it is already given in the prerequisites. Like you need Microsoft this Docker. You need WSL2. You will need VS Code is optional. Git is by default. You'll get it. And after that, Golang. Golang is very important because some of the smart contracts are written in Golang. Okay. So Go is a language in which the smart contracts are written, not the only language, but one of the preferred language from the Hyperledger Fabric side. So you have to install Golang. So what you can do is you have to search in the Google, install Golang in WSL. Here there will be a link from Dev Community. This is a good link. Like they have given a very good, very small number of steps to install Golang. Okay. So here you can install Golang on WSL2. They have given the steps that install Go by using these links, and then you have to perform these. You have to use these commands in WSL. So you can copy paste these commands and then keep on running those commands, and then you have to change the bash rc file. Okay, so you have to export, like you have to change the state variables or environment variables for that particular environment in WSL. So you have to export you have to create environment variables for Go that are Go root, Go path, and all that. So that
Samir,
Yes,
can
ma'am.
you tell that somebody is writing, AJK Prasad Ayagiri, he's writing that give steps to download and get ready for tomorrow lab session. So I think you are telling the same thing here.
Yes, ma'am. Yes,
Mr. Prasad Ayagiri, you can go through this video once again, and if what Samir is suggesting is go through this web page actually, and if you, Samir, you can also share in the link Google
Yes, ma'am.
folder that step by step. That would be great.
Yes, ma'am. Yes, ma'am.
Right?
Sure.
Thank you.
And there is one of them, ma'am, our old videos. Can we share that?
Yes, you can share.
So in the in YouTube, you can find it out how to install these things. In how to install Hyperlogic Fabric in
if you can
WSL.
share that video, that
Yes,
would be
better.
I think the participants will not have to search for.
Yes, ma'am. So I'm sharing this link right now. So this is 1 year old video. So right now, what I've shared with you is Docker will be same, WSL will be same. Only Golang, for Golang, I've already given you this link. So this is the Golang link. So you have to change this. So this is for Golang. So this YouTube video plus this Golang link. So all will be done, ma'am, with this video. They'll be able to ready their systems for Hyperlogic Fabric.
Thank you. Thanks. So there was a question by somebody, I think the same fellow, that when there is an ERP system, why do we need for student management? Why do we need this all? Well, good question. There are many applications which do not require decentralization, but there are many applications which require decentralization. Sitting at your home in New York, if you would like to have a transcript for applying in a postgraduate program, another postgraduate program that you wish to do 10 years later, and so you need a transcript from your institute. What is the current method? You tell me. You write to the Dean Academic will forward your application to the assistant registrar, who will look at it, who will again instruct some office assistant. And finally, the office assistant will look at the records and will issue you a transcript. The process will flow again. The office assistant will go to assistant registrar, who will go to the Dean Academic, who will go to the registrar, and so on and so forth, right? So it may take months, it may take 5 days, or it can be done on the click of a button if the application was a decentralized application. I think I have answered your question. With this, I would like once again all of you to please share your videos. With if you can put on your videos, so that we can have a screenshot.
Ma'am, you are muted, I think.
Thank you so much, all of you. I think Durgesh is taking a screenshot. Right. So thank you so much, all of you, for your patient listening to my lecture. And I appreciate your valuable inputs. I I hope that the sessions could be more interactive, and hope that in future, what happens when you are teaching and there are responses, you feel more encouraged to teach. So my suggestion to all of you is to please, if you can start interacting with the speakers, that would be great. Thank you so very much, all of you. We'll be meeting tomorrow. Till then, enjoy your time with your family and friends. We're meeting tomorrow. Thank you.